Okay, so we have a video here on rationalizing denominators. Now, what does it mean to rationalize a denominator? Well, let's take a look. When we have radical expressions, so remember, a radical is just an alternative way of representing a number that it is not pleasant to represent in another way. For example, we know that the square root of 3 is irrational, meaning it goes on forever, never repeats, and therefore is not a pleasant number to keep writing down as we do math. So we just leave it square root of 3. That's the exact form, as you may remember. But they are numbers, and we can do operations with them as we can any other number. Add, subtract, multiply, and divide, which is what you see here. The problem becomes, what if those radicals don't have anything in common? They don't cancel each other out. Now what? Okay, so technically, this is simplified, what you're seeing right here. The only thing else that I could do to it in terms of simplifying is to go to my calculator, figure out what 4 times the square root of 3 is, and divide it by the square root of 5. And I'll get some nasty decimal number. But maybe I don't want to do that. Maybe I've been asked to give an exact answer. Maybe I'm going to do something else with this number that having a decimal would be a problem. We have a rule in math which says that we should not leave radicals in the denominator. If we are going to continue on in the exact form, everything should be as much as possible on one level. But if we have to have a denominator, it should only be an integer, not a radical. By the way, this is the same reason that we say no negative exponents. It's also and very much a matter of what it looks like. Okay, all we're going to do, this is what the math that we're about to do here, all it's going to do is change the look of the problem. We're not actually going to change the value. It's actually very similar to what you did in grade school when you tried to add or subtract fractions and needed to alter the denominator in order to do that. Okay, 1/2 became 2/4, but those are still the same value. They just look different, right? So to rationalize the denominator, let's define this before we go any further. To rationalize the denominator means to remove any radicals in the denominator through multiplication. So the way that this works is the same way, like I said, that you would change a denominator when you were adding or subtracting fractions in grade school. So what we are going to do here is we are going to multiply by the radical, I'll write out the word there, in the original denominator. So it's square root of 5 here. So we are going to multiply by square root of 5. And we have to do that to the top and the bottom, right? Because that way we're going to just change the look of it without changing the value, right? Technically, square root of 5 over square root of 5 is 1. Anything times 1 is itself. Okay? So I guarantee you, if you were to grab a calculator when we're done and type in 4 root 3 over root 5 and what we're about to get, you'll get the same number. Okay? So 4 root 3 times root 5, we should remember that our multiplication rule says that we can multiply anything underneath a radical with anything else underneath a radical, and the things outside the radical only with other things outside the radical. There's nothing outside the root 5, so the 4 is alone. 3 times 5 is 15, that goes under the radical. Root 5 times root 5 is the square root of 25. That I can simplify. So it is 4 root 15 over 5. And that's the rationalized form. Now, two things to remember here. First, you may have to reduce. However, we don't in this case. However, that reducing can only happen with the denominator after you've gotten rid of the radical, so the 5 in this case, and the numbers outside the radical in the numerator, the 4 in this case. So don't worry about the fact that 5 and 15 can be canceled with each other. That doesn't work in this case because the 15 is under a radical and the 5 is not. The second thing to remember is that when you are going to do this multiplication and simplifying, pay attention to whether or not that radical in the numerator can also be broken down. 15 cannot be broken down. It's 3 times 5. There's not 2 copies of a number in there. And the 4 and the 5, 4/5 is simplest form. So like I said, this is simplified. However, it won't always be that way. Right? So this one's very similar. Hit pause and try it out yourself. So the result here is just the square root of 15. And let me just extend that so we make that clear. So root 3 over root 3, multiply by that, we would get 3 root 15 over the square root of 9, 3 times 3. We know the square root of 9 is 3, and like I mentioned on the last problem, you have to cancel the 2 3's. So that goes away, but the 15 is under a radical, so I can't cancel anything with 15 and 3. It just stays the square root of 15. Some people will ask, do I have to put 1 root 15? No, that's just the same reason we just write x instead of 1x. Some people will ask, do I need to say root 15 over 1? No, it's the same reason that we just would write a 3 instead of 3 over 1. So you do not need to add in 1s when you cancel here. Okay, the only exception to that would be as if the whole numerator canceled, right? It'd be 1 over whatever the denominator is, but in this case, that usually won't happen. All right. Now, number 4, our fourth problem, is a little bit different. Why is it different? Well, for a couple of reasons. The first reason is because the denominator has a number outside of the radical. There's 2 ways to deal with that. I will show you both. The second reason it's different is because the numerator is a binomial radical expression, meaning there are 2 terms there. That's going to change your multiplication at the end. So let's do the long way first, and then I'll show you the shortcut. So we have root 3 in the denominator, so that's what we should multiply both sides, or top and bottom, by. So we put in our root 3's, and then I'll do the denominator first. We would keep the 2, because 2 root 3 times root 3, there's nothing outside, so it stays 2, and then root 3 times itself becomes 9. In the numerator, we have to use the distributive property. So root 3 times negative 2 becomes negative 2 square root of 3 minus 2, and then we'll do 3 times 5 is 15. Okay. The next piece is I have to simplify the square root of 9, so the numerator for right now remains the same. And the denominator becomes 2 times 3. Okay. Now, with this, 2 things. 1, we would not have this step had we taken the shortcut, which I'll show you next. 2, with this, you can multiply 2 times 3 to get 6. I'm not going to do it because at this point I'm going to cancel something, and it's just going to be easier if I don't do the multiplication. What I want you to notice is each item here has a 2 with it. Okay? Both terms in the numerator have a 2, and the denominator has a 2. you are allowed to cancel out those 2's. So the numerator would become the square root of 3 negative, because the 2 goes away but not the negative sign, minus the square root of 15, everything over 3. Okay. The rule here, and you'll learn more about this in Algebra 2 when you study rational expressions, if you have something where there is a binomial over a monomial, or vice versa, you can only cancel whole factors, meaning if I want to cancel something, everything has to have it in common. Okay? I still cannot cancel the 3 under the radical, the 15 under the radical, and that last 3, because the first 3 and the 15 are under a radical, and the 1 in the denominator is not. Okay, I want to show you the shortcut before we move on. The shortcut, like I said, will get rid of that step with the highlighting. So I'll just recopy the problem. Negative 2 minus 2 square root of 5 over 2 square root of 3. You could have observed, and maybe some of you did, in the first step about the 3 2's, and you can actually get rid of them at that point. So then we would get negative 1. Remember when I said something in the numerator cancels, you actually have to put the 1 there. So negative 1 minus 1 root 5. I'm not going to write the 1 there. Over the square root of 3. I would still multiply both top and bottom by the square root of 3, which would get me negative, actually let me go to the side, negative square root of 3 minus the square root of 15. Again, that was the distributive property, just like we did before, over the square root of 9. And just as before, I would simplify the square root of 9 to a 3. So I would get negative square root of 3 minus the square root of 15 over 3. As you can see, it's the same as what we had the first time we did it. So you do the same steps, you do the same number of steps, it's just the order in which you do them. Some people like to cancel everything they see right away, makes it less work to cancel when they're finished. Other people like to do all their canceling at the end. It really doesn't matter what you choose. All right. Now, number 5 is a little bit different. Number 5 is different because, as you may remember, the square root of 18 is not in simplest form. You should put it in simplest form before you start to rationalize. So we're going to factor the 18, which is 9 times 2. And I know that there are two 3's inside of the 9, so that comes out. So we're going to have 3 minus the square root of 3 over 3 that came out, square root of 2 that I didn't circle. Okay, 3 root 2 is the simplified form of the square root of 18. And if you chose 6 times 3, you would have gotten the same result. Okay, now, in this case, I cannot cancel the 2 3's because notice that that minus square root of 3 does not have an integer 3 in front of it. Okay, so they don't all share a factor of 3. I can't cancel. But I do have to rationalize because that square root of 2 is still there. So I'm going to multiply top and bottom by square root of 2. Distributive property up top, 3 square root of 2 minus the square root of 6 over 3 square root of 4. I know that the square root of 4 is 2. And in this case, because nothing is going to cancel, okay, only 2 of the terms have a factor of 3. So that's not getting canceled. The radical is only in the numerator, no canceling there. Square root of 6 is already simplified, no canceling there. Since there is nothing left to cancel, this is going to be my final answer format. So I need to finish my multiplication in this case and make that 3 times 2 into a 6. Okay, so there's an example of one where we actually didn't end up canceling anything at the end. Now, I will tell you, I'm not going to go back and do this because I really don't recommend that you do, because I think it's best to cancel everything as soon as possible rather than as late as possible. Okay? So again, if you didn't cancel, or sorry, if you didn't simplify the 18, you would have had some canceling at the end. You would have basically introduced some common factors. Again, I think that's, like I said, that really is making an extra step and more work for yourself. So I really, like I said, would not advise doing that.